Okay, so we're getting started with Chapter 10, and Section 10-1 is really just an introduction to sequences and summation notation. So there's going to be a lot of new vocabulary in this section, so I've highlighted some of those terms for us. The first one is a sequence. Now a sequence is really just a list of numbers that follow a particular pattern. And we have infinite sequences and finite sequences. An infinite sequence goes on forever, it doesn't end, and there's no last term. A finite sequence does have an end, and it does have a last term. Now something else that you've learned previously in math is factorials. If I have n factorial, I'm multiplying all the way down to 1. We also define 0 factorial to equal 1. So for example, if I have, let's say, 5 factorial, that's 5 times 4 times 3 times 2 times 1. Now recursion formulas, the biggest thing we notice about those is that they have an a sub n minus 1 term. And basically what that means is that each term depends on the one before it. That's the way we're going to find each next term. So now that we've defined some of that vocabulary, let's go ahead and get into some examples. First it says, write the first 4 terms of the sequence. So typically we start at 1. So plugging in 1 here, I have negative 1/3. A sub 2, squaring this would be 1/9. A sub 3 would be negative 1/27. And a sub 4 would be 1/81. Okay. For the next one, we're doing the same thing, but we already know the first term. A sub 1 is equal to 2, a sub 2, a sub 3, and then we'll find a sub 4. And we need the term before it. So if I'm finding a sub 2, I need the term before it, a sub 1, and then we're multiplying by 5. So 2 times 5 is 10, and then 10 times 5 is 50. And then 50 times 5 is 250. Okay. Down to our next example. Now we have an example of factorials. Plugging in the first term. For the first term, plugging in 1. 1 minus 1 is 0. 0 factorial we defined as being equal to 1. So 1 times negative 2 is negative 2. And then plugging in 2, 2 minus 1 is 1. 1 factorial is 1 times negative 2 is negative 2. 3 minus 1 is 2. 2 factorial is 2 times 1 is 2 times negative 2 is negative 4. And then plugging in 4. 4 minus 1 is 3. 3 factorial is 3 times 2 times 1 is 6 times negative 2 is negative 12. And those are the first 4 terms. And then down to this next one, we want to evaluate this term here. Now, we know that 20 is going to be 20 times 19 times 18 times all the way down to 1. And we also know that 18 factorial is 18 all the way down to 1. And then we have 2 factorial, which is just 2 times 1. So we know right away that all these terms are going to cancel out. I can reduce 2 and 20, and I have 190. Now summation notation is a way that we can write out a sum in a shorter way. Okay, so this is our index here. Let's see here. This is our lower index, or our lower limit is another way we refer to it. This would be our upper limit. And then this right here, this I value, is our index of summation. So I'll zoom in on that for a second. And this I really should be a lower I. It should be a subscript here. A sub I. So that's our summation notation. Now let's actually do some examples on the next page. So it says find the sum from 1 to 5 of I cubed. So we have 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus 5 cubed. And that's equal to 225. We can look at our next example here, and it says express each sum using summation notation. So now we're given this and we want to rewrite it into summation notation. Well, each term is raised to the 4th power, so I think we can see that it's going to be I to the 4th power. We start at 1, so I equals 1, and we end at 12, so 12 up top. And that's all we have to do for that one. And then for this last one, we need to think a little bit more about this. Now this is 9 squared. This is supposed to be here 9 cubed. You can go ahead and change that to 9 cubed. And this is really 9 to the 1st power, even though we don't see it. And then we have a 1 here, a 1 here, a 2 here, a 2 here, a 3 here, a 3 here. So we can start to see a pattern. Maybe we have something like I over 9 to the I power. And we would start with I equals 1. And then we would have n on the top because we end at n. Okay. And that's the end of section 1, where we are just getting an introduction to sequences and summation notation.